Okay, this is Learning Target 16. We're going to do some more examples with the quadratic formula. And as we're working through these examples, let's just make sure we keep in mind, remember, quadratics can have no solutions, right? That would mean the U shape is going to be above the x-axis, facing an upward direction. It could have one solution, where it just touches the x-axis in one spot, or it could have two solutions where it hits in two spots. And just remember, these are all a values of a positive a value. You know, this U shape could be downward facing, so that would just mean it's the opposite, that the y-intercept would be below the x-axis and it would be facing down, and then vice versa, really, for all of these, right, in this case. So yeah, let's get into some examples here. Remember, here's our formula. Feel free to hum along the song here that you saw on yesterday's video. You're welcome for that song. Yeah. Example 1. Let's go ahead and get into it. Remember, first we'll go ahead and identify our A, B, and C values. Okay, so our A value here would be 4. Our B value would be -1, because this is a subtract x, so the coefficient here would be a -1. And then our C value here would be +3. Okay, and we're going to plug into our formula. I'll start it right here. Opposite of B would be +1, plus or minus the square root of B squared. B squared would be -1 squared. -1 times -1 is +1, minus 4 times A times C. Okay, and that's going to all be over 2 multiplied by A, which in this case would be 4. Okay, so going to just clean this up. I'm going to do this a little faster than I did yesterday. Just remember, we're always doing the stuff inside the square root first, and then we're going to make sure we take care of all this multiplication before we do any subtraction. So 4 times 4 is 16. Multiplied by 3 is going to be 48. 16 multiplied by 3. And if you guys are okay, I'm going to put this as 48, and then 1 subtract 48 would be -47, right? So 1 plus or minus -47, all divided by 2 multiplied by 4 would be 8. Okay, so square root of a negative number. We know that that's a problem, right? This creates an imaginary number. It doesn't work. So what does that mean? Well, if you think back to last week's notes, when we took a square root of a negative number, what did it mean? It basically is going to mean that this quadratic function is going to be above the x-axis. So this quadratic function has no solutions. So if you ever end up, when you're using your formula, if you ever end up with a negative square root, then there is no solutions. And that's what we would write. This answer would be no real solutions, no numbers that are going to make this work. Okay, so that's the first example, and then you could just stop there if you ever get a negative for the square root. Okay, let's try another example. Okay, get our A value, B value, and C value. A value is 1, B value is -6, C value is 9. Plug it into our formula. Opposite of B, 6, plus or minus the square root of B squared, which -6 multiplied by -6 would be +36, minus 4 times A times C, all divided by 2A. Okay, take care of my stuff inside the parentheses here. 4 multiplied by 1 multiplied by 9 would be 36. 36 minus 36 would be 0. 2 multiplied by 1 would be 2. Square root of 0 is 0. Now, I'm going to write the next step here, but for now, we'll come to a conclusion here. So 6 plus or minus 0. So if I were to break this off into the two things like we did yesterday, essentially what I'm going to have, if I were to break this off into the two parts like we did in yesterday's video, I'm going to have the same. 6 plus 0 divided by 2 is the same as 6 minus 0 divided by 2. So whenever you get 0 in the square root, there's just going to be one solution. Right? Meaning that this is just going to touch in one spot on the x-axis. And so we could, just quickly do that. 6 divided by 2, right? Because this is just 0. 6 divided by 2 is 3. So your solution would just be x equals 3. So this would only have one solution. It would just hit the x-axis in one spot. Okay, so we're kind of coming along here. I mean, when we see a negative, we just know it's not going to touch the x-axis, so there's no solutions. When we see a 0 here, there's just going to be one solution, and it's just going to be this number divided by this number would give us the solution. All right, and let's take a look at another example. Okay. All right, so identify our A, B, and C. A is 2, B is 4, C is negative 3. Plug into our formula. Opposite of B is negative 4, plus or minus the square root of B squared, which in this case would be 4 squared, which is 16, minus 4 times A times C. All divided by 2A, which is 2 times 2. Okay, clean this up a little bit. Negative 4 plus or minus the square root. Go ahead and try to take care of all this. 4 times 2 is going to be 8, multiplied by negative 3 is going to be negative 24. So this right here would be negative 24, and we're subtracting a negative 24. Maybe just show this off to the side. Right, we're subtracting a negative, so this is really like adding. So 16 plus 24 would be 40. Okay, all divided by 4. Okay, and if you remember from yesterday's video, this is not going to be a perfect square, right? Because it would be 36 and 49, so this is going to be somewhere in between 6 and 7 if we take the square root of it. But remember, as soon as we take the square root of this, we immediately have a non-exact answer. This would be an irrational number, and we don't like that because it's not going to give us an exact x-intercept. So we're allowed to just leave it like this, but notice how this would have two solutions, right? Because you would have, this is a square root of a positive number, so you would have negative 4 plus that number, and you would have negative 4 minus that number, and that would give us different numbers if we were to do it. You could see yesterday's example. So whenever we have the square root of a positive number, we know we're guaranteed there's going to be two solutions. It's going to hit the x-axis in two spots, and we are okay with just leaving it like that. Now, if this were a perfect square, then we could go off and branch off into equations and do those. And if you need to look at yesterday's example for help on that, you can. If you still have questions, feel free to stop into the Zoom meeting. I'll do a few more examples for you guys. Thanks for watching.